Alright, so what we're going to look at is what's called the triangle sum theorem. And this is what we worked on with the exploration today. So what we're going to do, so we're going to draw a triangle. So there's our triangle. Triangle A, B, C. And the triangle sum theorem says that if I take the measure of angle A, that's a C, plus the measure of angle B, plus the measure of angle C, that all three of those angles are going to add up to 180 degrees. And that's what we found during the exploration. If I take each of these angles in turn and pull them out and put them next to each other, they will form a straight line. There you guys go. So we're going to be using this theorem mostly to try to calculate the missing angles. Kaylee? I'm working here. Missing angles inside a triangle. So for example, if I were to tell you that this angle here was 110 degrees, and this angle here was 30 degrees, and I asked you what this angle here was, you can use the triangle sum theorem to say that x plus 30 plus 110 is 180 degrees. Now the key to the triangle sum theorem, like all the other theorems we've worked with so far this year, is to always be thinking in terms of writing an equation that you can turn around and solve. Don't let yourself get hung up on do I add or do I subtract. Focus on the equation, because then you can follow exactly what you have to solve it, which in this case is to subtract 30 from both sides and subtract 110 from both sides. The end result, x must be 40 degrees. Now, we're going to be doing a lot more of these as we go through, but let's talk about the other theorem here. The second theorem in section 4-2 is the harder one to get around, partially because you can solve some of the problems without using it, simply by using other rules that we've talked about. Now, a little later on this year, we'll actually write the proof of these theorems. But for now, it's about the using that matters. The remote exterior angle theorem talks about what it sounds like, remote exterior angles. So, if I have a triangle right here, so there's my triangle, and I extend that side over there. I'm going to point it over here at Kaylee. Say hi, Kaylee. Say hi.
Hi.
There we go. Now, this angle right here, that angle, is going to equal the sum of the remote angles away from it. That would be this angle and this angle. So if I were to label these angles 1, 2, and 3, let's call it 4. Call this guy 3. Kaylee, we need that. Yeah, okay. Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. That's what that says. This angle plus this angle will equal this outside angle here. Now we already know that 1, 2, and 3 are going to equal 180 degrees. We also know that 3 and 4 are going to equal 180 degrees because they're a linear pair. So what this theorem adds to our collection of knowledge is that I can talk about how this angle plus this will just equal this one out here. So again, if I had some concrete numbers to work with, I could say, let's say this angle out here is 120 degrees. Maybe this angle up here is 80. Kaylee. Anyway, so 120 out here. Now we know what this angle here would have to be. It makes a line, right? So since there's a straight line there, Kaylee, go over there. There you go. Since there's a straight line here, that's going to be 60. And think about that. 120 plus x is equal to 180. Solve it for x. So when I want to find out what angle 2 is, so back to the blue, I can talk about how 2 plus 80 is going to equal 120. The two remote angles add up to the exterior angle. So I could write 80 plus x equals 120. Solve for x. X is 40. And that should make some sense when you think about it. Plus, I can also look at this has to add up to 180 degrees in here. 60, 80, and what will give me 180? The missing angle is going to be 40 degrees again. As long as I'm working with concrete angles, this tends to work pretty easily. It's when we add in the variables that you really have to know this formula. And that'll be the first of the problems we look at when we get back to when we continue this. Let's take a look at another triangle type problem that's going to use the remote exterior angle theorem. Now in this case, I could probably still get away without using it by doing some heavy reasoning, but I think this one tends to be a little easier if we just apply the rule. Remember, the theorem says that if I take an exterior angle and compare it to the two remote angles, that their sums should be the same. That is to say that in this case, x plus x should equal 140. And for clarity, this x is this x, and this x is this x. So, I can now add these together. 2x is equal to 140, divided by 2, x is 70. So in other words, these angles up here must be 70 and 70. And that comes again from the idea that the two angles opposite the exterior angle should add up to that exterior angle. 70 plus 70 is going to have to be 140. Now I could get the same answer by perhaps reasoning out that this angle must be 40, because this is a straight line here, and then using that straight line in order to figure out what these guys have to be. You can use the triangle sum theorem. But in this case, it's a lot more efficient to go to a theorem that fits the situation better, the exterior angle theorem.